Good morning, everybody. So in our today's class, we are going to study the next one is, what is that, guys? Newton's second law. Understanding Newton's second law of motion. So now if it comes to know Newton's second law of motion, so as we know before, if you want to understand the Newton's second law of motion, so you need to know the word called as, which we already studied in the last class. What is that word? Anybody? That is
Momentum.
momentum. So what is the symbol of momentum? How we can represent? P. Understand? That is what. So momentum P is equals to, in last class we already derived the formula. That is what? It is a product of two things. That is what? Mass and velocity. So that is why it is a vector quantity or scalar quantity. It is the vector quantity. That is what you have to remember. Now, if you'll notice it very carefully, in last class we have been proved that, of course, what is the units of momentum? Anybody? What is the units of momentum? Kilogram meter per second. This is what the units of momentum are. CGS unit. What is the CGS unit, guys? Gram centimeter per second. This is what the CGS unit, and this is what the SI unit of momentum. Now, in last class, we have been proved two statements. Do you remember? For example, now a car, once again, I'm revising because today we are going to start with that only. Now, car, Danishkar is driving the car. Now, Arun Kailas is driving a truck. Now, as we all know people very well, now, for example, both car and truck has been, car has been hit by the person, one person, and the truck is also hit by the person. Now, you tell me, in which case he will be injured more? In which case he will be injured more? Yes, in the truck case. Why he's been truck case, he's been injured more? Because more large momentum or small momentum? Everybody. Arun Kailas? Large momentum. So large momentum is exerted. So why it is large momentum is exerted? Anyone? Because of why? Because of more mass. Understanding, because of its more mass, so large momentum is exerted so that the person will injury more. Is it yes or no? Injury will be high. So that is what will happen. Now, this is the first case, but both the speed are what? What velocity is constant or not? Velocity is constant. Same. You understand? So even though velocity is same, understanding. So the body which is having more mass will exert more momentum on the what? That is what the first statement we made. Now, same two cars I have taken. So same two cars means, what is that, guys? What is about their mass? What about their masses? Mass same. Is same. But who is where is Radhanishka? Mass is same. Understanding? So both are same cars. So mass is remains same. So then who will varies? Different velocity. For example, it is 30 meter per second. And let me take, this is 100 meter per second. Now, both are hitting a one person. Then you tell me in which case you will be injured more? Which case? In 100 meter per second. Why here? What is that? Velocity is greater. So greater the velocity, then higher will be the what? Then momentum. Higher will be the momentum. That is what we have been proved. Yes or no? Yes, please respond. Higher will be the momentum. Yes, understand? Now, with this today's class, we are going to continue with this statement only. Now, here velocity is more means applied force is more or less. That is what my question. Applied force is more or less. More. Applied force is more. Is it yes or no, Hari? Will you accept this? Ready? Because I'm increasing the velocity means in the sense of what? I'm accelerating. I'm accelerating means fuel consumption is more or not? More fuel consumption. So more it will be exerting the force. Yes or no, guys? Will you accept it, everybody? Harish? Yes, sir. Yes, that is what you have to remember it. So whenever I am exerting the more force, then automatically the velocity will be rises. When the velocity is rising, what will happen? Then momentum also increases. Yes or no, guys? So that is what, with the same statement we are going to start today. So Newton's second law of motion will says that when the force acting on a body changes, then what will changes? momentum also will changes. Yes or no, guys? Yes, please respond. When a force acts on your body, always the momentum of the body will changes. Yes or no? Vartani, Mitakshri, Vartani, that is what will happen. Now, if I'll apply larger the force, then what will happen the momentum? Anybody? Larger the force, what will happen the momentum? Yes, please respond. Larger the force means the force is more. So what about the momentum I am asking? Greater will be the force. Do you understanding? So if I applied force is more, then what about the momentum, guys? What will be the change in momentum? Greater will be the change in momentum. The larger the force, greater will be the change in momentum. So that is what. So the Newton's second law will give you the relationship between force and momentum. Do you understand, everybody? Please respond. Yes or no?
Yes, sir.
Newton's second law will give you the relationship between force and momentum. That is what, if the force is increasing, then momentum will increase or decreases. Please respond. Momentum or decreases or increases? Momentum will increases. Understand? So now let us comes to the, what do you mean by Newton's second law of motion according to your textbook? So you all having a textbook, correct, guys? Everybody NCERT book you have, and as well as one practice book also you have. Yes or no, please? Everybody respond. Now, will we go with our
Yes,
own
sir.
method or we'll go with our textbook method? First, let us learn our textbook. Later, we'll go with different formulas and different things. Is it okay, Hari? Yes, please respond. That is what. Okay, everybody. Now, notice it. What do you mean by Newton's second law of motion means? Remember, as we know, when two bodies, heavy one and light one, are acted upon the same force, then who will exert more? Who will exert more for momentum, guys? The body which is having more force or more mass will exert the more force. So same way, the two bodies I have been given, one is heavy body and lighter body. Now, both I applied at same 10 Newton force, for example, imagine, then which will acquire the more velocity, faster, car or truck? If I apply the same force, who will acquire the more velocity, car or truck? Yes, please respond. Hari? I have given, suppose now this is the car and this is the truck. Now I applied the same amount of force, 10 Newton force and 10 Newton force. Then whose velocity will be more, whose velocity will be less?
Truck velocity more.
Truck velocity more. Truck velocity more. Am I asking truck velocity more? Check it very carefully. I am asking now question is, observe very carefully. I'm having one car. Observe very carefully. Now, car is having less mass or more mass? Less mass. Do you understand? Now, I am having one truck. Now, this is what my truck. Understand, everyone? Now, I am applying the force, same amount of force. Let me imagine 100 Newton of force. Here also 100 Newton of force. Now, tell me, in which one the velocity is more, I am asking. In which one velocity is more? In car. In car, velocity is more. Why car velocity is more? Velocity is more. Yes. So when you are applying the constant force or same force, keep in mind all of you, when I'm applying the same amount of force in two different bodies, which is having different mass. So which body will attain more velocity? The body which is having less mass or more mass, guys? Less mass or more mass?
Less mass.
Less mass. Because that is what, for example, I have given you 1 kg stone and a 10 kg stone. Which one you can throw easily? Anybody? Which one we can throw easily?
1 kg.
1 kg. Why 1 kg? Because of its what? Because of its less mass. Understand? So that is what you have to remember. But I am saying that, observe, what about the total momentum? Momentum is same or not? Of course, mass is different, but applied force is same. So that, what about the momentum? That is what my question. Momentum is same or different? Momentum is same or different? That is what my question. For example, I will prove it. Try to understand very carefully. For example, let me take car. Car is having a mass of 1 kg. How much? Car is having a mass of how much?
1 kg.
Understand? Now truck is having a mass of 10 kg. Let me consider. Now I applied force is same. I applied 10 Newton force and I applied here also how much force? How much force, Ra? 10 Newton force.
Newton.
Understand? Now, because of this 10 Newton force, its velocity attained is 10 meter per second, and here velocity attained is 1 meter per second. Now calculate the momentum of the car. Anybody? What is the momentum of the car and momentum of the truck? Let me see who will say. What is the momentum of the car? Mass of the car into velocity of the car. Mass of the car is 1 kg into velocity of the car is how much, guys? 10 meter per second, which is equals to 10 kilogram meter per second. Is it yes or no? Everybody will you accept it or not? Mitakshri, Gokul?
Yes, sir.
Yes. Now,
Both are same.
yeah, calculate the momentum of the truck. Ready? Arun Kailash, momentum of the truck I want. Momentum of the truck is equals to what, guys? Mass of the truck into velocity of the truck. Mass of the truck is how much? 10 kilogram into velocity is equals to 1 meter per second, which is equals to 10 kilogram meter per second. Is it right or wrong? Everybody? Yes, please.
Yes, sir.
From this, we have been proved that momentum of car, which is equals to what? Momentum of truck. Understand?
Car.
So why it is? Of course, their attained velocity is different, but applied force is what, Hari? Applied force is what? Applied force is
Same.
same. Do you understanding? That is what you have to remember. So even though two different bodies, heavy body and lighter body, of course the light body will attain more velocity, but of course finally the momentum gained by the both the bodies is same or different? Please respond. Is it same or different, guys?
Same.
Same only.
Same.
That is what Newton's second law. Do you understand? So according to this is what the link between the force and momentum is expressed in the Newton's second law. Do you understand, guys? That is what we are going to study. What is the relationship between force applied and change in momentum? So momentum also I told you in last class. Also we can call it as what? Linear momentum. Understand? So Newton's second law will give you the relationship between what? Gokul, Danishka, Kaushik, anybody. It will give you the relationship between what? It will give you the relationship between force and momentum.
Momentum.
So that is what Newton's second law. Newton's second law will says that. What is Newton's second law? It has been given in our textbook, page number 58. All of you open page number 58 in our practice book, and you can see the Kaushik. You don't have no problem. You can listen. Okay. Now what Newton's second law will says that the rate of change of momentum is directly proportional to applied force, and understand it will be where it will be acting, direction in which the force is acting. That is why it is what we used to call it as vector quantity. Always the force applied is in the same direction of displacement. Understand? So that is what you people need to remember. So momentum is a vector quantity or scalar quantity? Everybody, momentum is a vector quantity or scalar quantity?
Vector
Quantity. Always direction matters. So what I already mentioned you from the long back, rate of change of momentum means in the sense of what? With respect to what, Hari? Girls, remember in mind, whenever you will get a rate of, it is indicating that with respect to time. What is that? With respect to what? Time. Do you understand?
Time.
That is what. So according to the Newton's second law of motion, what it will say means the rate of change of momentum of a body is directly proportional to the applied force. Understand? And it takes place in the direction in which the force is acting. So if the force is acting in this direction, then momentum is what is the direction of momentum? Direction of momentum also in same direction. Understand? Now if the force is acting in this direction, what about the momentum? Anybody? What about the momentum? The momentum also in the same direction. Please remember. So whatever the direction of force is acting in the same direction, who will act? Who will act?
Momentum.
Momentum also will act in the same direction. So, what is Newton's second law? It is the rate of change of momentum. Please, all of you learn, write it. Rate of change of momentum, right? According to the Newton's second law of motion, write it. According to the Newton's second law of motion, the rate of change of momentum, everybody write it. The rate of change of momentum of a body, the rate of change of momentum of a body is directly proportional to the, what guys? Directly proportional to whom? Mitakshri? Directly proportional to whom?
Applied force, sir.
Applied force, very good. Directly proportional to the applied force, comma, and it takes place in the, which direction? Danishkar? Takes place in the direction in which the force acts. In which the force acts. In which the force acts. Is it okay, guys? Please respond. That is what you have to remember. Now, as I told you, what do you mean by rate of? What I said? What do you mean by rate of? Rate of change of momentum. Anybody? Change of momentum. Please remember, whenever you will get a rate of, remember it is with respect to time taken. That is the first thing you have to remember. Okay, guys? Yes, please respond, everybody. Understand? So as we know, what is the relationship between force and momentum? Directly or inversely proportional? Both are directly proportional.
Directly proportional.
So the definition is rate of change of momentum, understanding, with respect to what? Applied force. Understand? The rate of change of momentum of a body is directly proportional to applied force. So the formula will turns into the force applied is directly proportional to rate of change of momentum. That is what? Change in momentum. What we used to call? Please respond, everybody. What is that? Change in momentum divided by rate of. What do you mean by rate of? Rate of means what? Time taken. Understand? That is what you have to remember it. Now, in first chapter and all, if you want to remove the proportionality and if you want to bring the equals to, then what we have to take? We have to take some constant. What do we have to take? We have to take the some constant. That is what we can take. So force is equals to constant into change in momentum. What is that, guys? Change in
Momentum.
change in momentum divided by time taken. Divided by time taken. Now go to the chapter 1 and tell me change in velocity means what we written, Hari, Gokul, Reddy, anybody? Change in velocity means what we have written. Anyone tell me?
Sir, accident.
Acceleration. That is what we have written. Rate of change of velocity. What we used to call? Rate of change in velocity is only called as acceleration. I'm asking Hari, only change in velocity. Change in velocity means we written something which is equals to something we written. Anybody can tell? Arun Kailash, open your mouth. Gokul also. What do you mean by change in velocity? Anybody can tell me? We written, check in your notebook and tell me. Change in velocity means final velocity minus initial velocity. Do you remember? Final
minus u.
minus initial velocity. Yes or no, guys? Please respond. Everybody.
Yes,
Same way, we don't have any use of this, but here also it is coming. Force is equals to constant into change in velocity. Change in velocity means what I can write? Anybody? Change in velocity means what I can, sorry, change in momentum. Change in momentum means what I can write? Final momentum. Understanding? Final momentum minus what I can write?
Initial momentum.
Initial momentum. Do you understanding? Initial momentum divided by what is that?
Time taken.
Time taken. That is what you have to remember. Is it okay, da? Everybody? Please respond, guys. Now, let me consider example. One car is present. Its initial velocity I can consider U or V. Initial velocity.
U.
U, understand? And mass is constant. Now, after certain time, the car is attained some velocity. That velocity, what we used to call, Gokul? We used to call that
Final velocity.
velocity. Mass is remains same. Now, in this case, what is momentum? Anybody can tell me? What is the momentum in this case? Let me consider this is P1. So P1 is equals to mass into initial velocity. Let me consider in this case P2. What is the formula here? Mass into final velocity.
Final velocity.
That is what. Now, change in momentum means you will take what you are written formula. Change in momentum means you have to tell me. Change in momentum. You should tell me formula. Change in momentum.
Final minus.
Consider P is equals to what will come? Final
Final
momentum.
minus.
That is what P2
Initial.
minus initial momentum P1. Can I write it or not? Right or wrong? Everybody should say.
Yes, sir.
That is what. So I say force is equals to what is that? Constant into final momentum minus initial momentum divided by time taken. What is the symbol? Ready? Time taken is T. Understand? That is what. Kaushik, you also try to answer at this. This is this chapter only correct. This is you have to say. Now F is equals to K into what is final momentum formula? Mass into final velocity minus initial momentum formula. Mass into initial velocity divided by time period. Any doubt, guys? Any doubt?
No, sir.
F is equals to K into, in this one is constant. Who is constant? Check it, everybody. What is constant? K is constant. K not. In this MV and MU, someone is the same. What is M is same. Can you bring it? M is outside and divided by V minus U by T. Yes, please respond, everyone.
Yes, sir.
Yes, of
Yes,
course.
sir.
Now, K into M into V minus U by T, which is equals to something. Girls, Mitakshri, you studied already. V minus U by T, which is equals to something. What is that? Can you tell me? From the chapter 1. From chapter 1. Just now, even today also I taught. Just now I taught. That is what? What is that? Change in velocity. Final velocity minus initial velocity. That is what? Final velocity minus initial velocity divided by time, which is equals to what, guys? Which is acceleration. That is what. So, can I replace with that V minus U by T with acceleration? Yes, please respond. That is what. So, I can replace this full term with the acceleration. Now, force applied is equals to K into M into A. This is only formula for what law? Newton's second law. Understand? But as we know, in SI unit, K is the constant, as we all people know. So the value of constant K in SI units is, we'll take 1. What is the SI unit of K value? In SI unit, K value is considered as 1. What is the K value, everybody? What is the K value? 1 will consider. So I will replace with that. F is equals to 1 into MA. So anything into 1, same thing will come. So what is the formula? What is the formula? Second law. Force applied equals to, that is what? Force applied is equals to mass of the body into acceleration of the body. This is only called as, what is to call? Newton's second law of motion. What is to call? Everybody, please respond.
Newton's second law of
Newton's second law of motion.
Motion. That is what you have to remember. Okay. Now, from this, anybody can tell me what is the acceleration formula? So, of course, I can write now. F is equals to M into A. Now, I want from this, as we know, acceleration is equals to final velocity minus initial velocity by time. But I don't want this one. From this one, I want acceleration formula. Anybody can tell me?
So F by M is equal to S, sir.
Very good. Now, what is the relationship between force and mass? Anyone can tell me? Gokul, Danishkar, Kaushik. Force is directly proportional to mass. Same way, force is directly proportional to what? Acceleration. That is what you have to remember. Now, if the force is increases, what about the mass? Mass is also
increases.
Now, if mass is decreases, then what about the force? Force is also
Decreases.
If force is increasing, acceleration, what will happen? Increases.
Increases.
If acceleration is decreasing, then force about what? decreases. Okay, that is what you have to remember. Now, from this formula, I will write acceleration formula. I want acceleration. Keep acceleration one side and mass is in multiplication. Will come this side. What will become? Everybody? What will become?
Division, sir.
Division. You understand? That is what you have to remember. Now, can anybody tell me what is the relationship between acceleration and force? Acceleration and force. Acceleration and force is directly proportional to each other. But acceleration and mass, what is the relation? Acceleration and mass. Anybody? What is the relation? Acceleration and mass? Directly or inversely proportional?
Directly.
Directly.
Inversely.
Where directly? It is in the same level or division, yeah? Where it is directly? Acceleration and force is both are same level. So acceleration increases, force is increases. Now acceleration decreases, then what will happen? Force is also decreases. Okay. Now, what is the relationship between acceleration and mass? I am asking. What is the relationship between acceleration and mass? Both are inversely proportional to each other. Please remember that. Inversely. Why it is inversely? Because mass is in division and you can see A is in up. So for example, I am asking you, I have given you 1 kg stone and a 10 kg stone. I have applied the same amount of force. Force is constant, same. Understand? Now you tell me which body you can create more acceleration, small body or big body? Which body you can create
Small
more
body.
acceleration? Yes. Small body, more acceleration, less acceleration. Why here less acceleration, here more acceleration? Anybody? Girls?
Mass difference.
Because here more mass. That is what? So more mass, less acceleration. Here less mass, so that more acceleration. So that both are inversely proportional, directly proportional, guys. You should speak. Inversely proportional to each other. Do you understand? So proportional to each other. Kaushik, have you understand, Kaushik? Relationship between mass and acceleration. Next chapter also it will come. Please remember that. Now that is what you have to remember. Okay. Now for example, you all people tell me if acceleration, let me take force and acceleration. What is the relation between force and acceleration? Force and acceleration. Anybody? What is the acceleration and force relation? Directly proportional to each other. If you are not opening mouth, I don't want anybody. I'm saying you. How many times I'm saying? What is the relationship between acceleration and force? Acceleration and force.
Directly
Proportional to each other. Now, if body acceleration become double in the sense of A become 2A, then what about the force? I'm asking. What about the force? Force also become 2F. That is what it will be happen. Very good. Are you clear, everybody? If acceleration will become double, then force also will become double. Why? Both are directly proportional.
proportional.
If A become A by 2, if A become A by 2, then what about force? Then what about force?
F by 2.
Become half.
F by 2.
Everybody. Clear, everyone? Any doubt? Clear? Now, same way, force is directly proportional to mass. Now you tell me, if F become 2F, then what about the mass? What about the mass?
2M.
2M. Understand? Now, if F become F by 2, then what about the mass?
M by 2.
M by 2. Because this is also directly or inversely proportional.
Directly proportional.
Try to understand. Okay. Now, last relation, one inverse relation we have. What is that? Acceleration is inversely proportional to mass, or mass is inversely proportional to acceleration. Both are same. Yes or no, guys? One increases, another one is decreases. Now, my question is, let me take now acceleration become 2A. A become 2A. What about the mass? That is what my question. Anybody?
So 1 by 2M.
2A. Then mass will become what? Yes, please.
Sir, 1 by 2M.
Very good. 1 by 2M. How to prove it? Let me take. Now, let me consider this is the equation number 1. Is it okay, guys? Anybody having doubt? Please respond. Anybody's having doubt?
No, sir.
Now, they're saying A become what? A become what? A become what, guys? A become 2A. Do you understand? Now, what about mass they are asking? So, both are inversely proportional to each other. So, observe very carefully. Now, in place of A, all of you notice it here. Observe very carefully. Now, if mass will become, see, acceleration become double in the sense of mass will become what, Hari? Mass will become m by 2. Do you understand, everyone? So that is what the relation, because let me take now, m is directly proportional to 1 by a. Now we know that m is directly proportional to 1 by a. Now a become how much, guys? A become how much? A become how much, guys? 2a.
2A.
2a means in the sense of, can I write like this? Observe very carefully. M by 2a. Is it okay, guys? Yeah, m is directly
Yes, sir.
proportional to 2a like that. Now, as we all people know, m will become 1 by 2 separately into 1 by a. 1 by a is equals to what? We know that. 1 by a is equals to what? 1 by a is equals to what? 1 by a is equals to what it is? Axial mass it is. So, in place of 1 by a, I can write m. So, m by 2 it will become. Mass will become what? If acceleration become double, mass will become what, guys? Mass will become half. Understand? That is what you have to remember it. Now, if mass will become double, anybody can tell me? Mass will become double. Then what about the acceleration? Anyone?
Acceleration become half. Sir.
Acceleration.
Sir, A by 2.
A become a by 2. That is what you have to remember it, all of you. Okay? Because we know that, observe very carefully. Now, acceleration is directly proportional to, sorry, inversely proportional to mass. Now, m become what? What ready? M become what? Second, let me take this is the equation 1. Now, second equation, acceleration 1, m become what? M become 2m. Yes or no, guys? M become 2m. So now I will write as this one 1 by 2 into 1 by m. Is it yes or no? 1 by 2 into 1 by m. So 1 by m is equals to what? We know that. 1 by m is equals to what? Acceleration.
Acceleration.
So 1 by 2 into a. So which is equals to a by 2. So a by 2 means acceleration become how much, guys? Acceleration
Half.
how much? That is what. So please put a statement. If acceleration doubles, if a become doubled, then mass become what? Then m becomes half, or we can say halved. Okay. Same way, if m become doubled, if m become doubled, then acceleration become what? Halved. Okay. That is what you have to remember it. Next, if acceleration is halved, then what about the mass? Mass will become doubled. Understand?
Double.
Yes. If mass become halved, then what about the acceleration? Then
Double.
acceleration
Doubled.
become doubled. Mitakshri, have you understand Mitakshri clearly?
Yes,
Yes.
sir.
Very good. So that is the relationship between force and acceleration. Same way, force and mass. So sorry, mass and acceleration. What is the relationship between acceleration and mass? Kaushik, both are inversely or directly proportional each other. Acceleration and mass. Arun Kailash.
Inversely.
Inverse.
Proportional to each other. That is what you have to remember. Acceleration and force. Kaushik.
Directly proportional.
Directly
Properly.
proportional to each other.
Directly proportional.
Understand? Arun Kailash, you cannot answer. That is what? What about the force and mass? Force and mass relation.
Directly
Force
proportional.
and mass directly proportional to each other. Understand, everybody? So this is what we used to call as Newton's second law. Please, all of you solve from here. Let it be. This is our textbook method. Then we will see again the next method which we are going to study in different way. That is what in the form of a higher order method which we'll study in our tomorrow's class or possible today itself. So now try to solve this definition, everyone. So have you understand Newton's second law? What is Newton's second law? Rate of
Yes, sir.
change of momentum. What is Newton's second law? Rate of
Rate of change of
Change of momentum.
momentum.
Force. That is what Newton's second law. So what is the relation? Finally, conclusions we have to make it. What is that? Force is directly proportional to mass and acceleration, and mass is inversely proportional to acceleration.
Acceleration.
That is what you have to remember. So force is increases, mass is increases, or force increases, acceleration increases. But if acceleration increases, mass is decreases. If mass is increasing, acceleration, what will happen? Acceleration will
Decreases.
decreases. That is what. So this is the Newton's second law of motion. Everybody should solve. In SI unit, what is the K value, guys? In SI unit, what is the K value? Constant.
1.
1. That is why. So K is equals to 1. Proportionality constant. What we used to call? Constant of proportionality. K is equals to 1.